Everyone, this video is about factor notation and operations expressing factors. We can use uppercase A capital B with a line on top. This means from A to B, or we can use column factor like this. This is again from A to B, from the coordinates of A to 3, B 6 8. So from A to B, this is like translation. We go 4 units to the right and 5 units upwards. You can also use lowercase a, just one letter, or a with a bold if you are typing it, and column factors. This is like in a column in 2 dimensions, in 3 dimensions, and we always use 3 dimensions actually in paper 3. And we can also use Cartesian components, so like with I, j, k, the I means for the x component, j for y component, k for the z component. And constant times factor, so we have a number times a factor. This is like a scalar constant times a factor. We get ka, I mean this is b, ka, k, b, oops, okay, I mean this is b, ka, k, b. And if we have, for example, 7 times 2 over 2 3, we get 7 times 2, 7 times 3, 1/2 times 3 over 2, and so on. So we just multiply. Minus times, we can just multiply. And for factor times factor, so this is a simple number, so a coefficient or scalar times factor. So we have factor times factor, aka scalar multiplication or dot product. So here you have a factor times a factor, we get a scalar. So it's called a scalar multiplication, not because we are multiplying by a scalar, but because the result is a scalar. The result is not a factor. We have only a number, a magnitude without direction. So for example, in 2 dimensions, 2 times 4, 3 times 5, or in 3D, minus 2 times minus 4, 0 times 5, 3 times minus 6. We get a simple number or a scalar. So in MF19 you see this formula, the only formula about factors. So this is for the previous formula for the multiplication. This is how we multiply, remember. So this is how we multiply. We get a dot b, but a dot b is also equal to the magnitude of a times the magnitude of b times cos theta. So this symbol, the modulo symbol, means the magnitude. Now remember, for the direction, if we are finding a dot b, remember that the factor a and the factor b must both start with exactly the same point, or they are heading to exactly the same point. Okay, so if the a is going to the right and the b is going like in this direction, it doesn't work. So they must have the same initial position or ending position, and the theta would be the angle between them. So in case you're wondering how do we calculate the magnitude, well, it's just like Pythagoras. If the factor is like a is for the x component, b is for the y component, so going to the right, going up, you use Pythagoras, you get a squared plus b squared. So same concept here, but in 3D, just like finding the diagonal of a cube. So we again, like this, take the square root of everything squared and you add. So yeah, just like this, for example. And now we have parallel factors. So parallel means the angle between the factors is 0 or 180 degrees. So because we have this formula and this formula and this formula, you can just use the formulas. For example, here, find the angle between this factor and this factor. So we have 2 minus 3 6, we use this form. B minus 4 6 minus 12, you can find the magnitude. And a dot b equals 2 times minus 4 minus 3 times 6, 6 times minus 12. We have a dot b, and we use this formula now. The a dot b equals the magnitude of a, magnitude of b cos theta, so we can find the theta. And here, as you can see, we have the b equals, the angle is 180 degrees. 180 degrees or 0 degrees means parallel. Okay, so when it's parallel, actually the a factor a must be some multiple of the factor b. So in this example, the factor a is minus 4 6 minus 12, the b is 2 minus 3 6. Actually, the b is some number times a. So this number can be a fraction, it can be decimals, can be anything, and the sign can be positive or negative. So parallel factors. Perpendicular means the angle is 90 degrees. Remember that cos 90 degrees is 0, so basically a dot b equals 0 here. So for example, in case you want to find the magnitude, find the a dot b, you get 0. So of course, if you use this formula, 0 equals magnitude of a, magnitude of b cos theta. The theta is just 90 degrees. So you don't have to find the magnitude actually, because if the a dot b is 0, of course it's perpendicular. So this is the perpendicular symbol, upside down t, a perpendicular to b, so a dot b equals 0. And next we have the unit factor. We call this a hat. So we use like the cap symbol. This means the factor a divided by the magnitude of that factor. So for example, in 2 dimensions, the magnitude is 5, so minus 3 divided by 5, 4 divided by 5, we get this. And in 3 dimensions, you can find the magnitude, all the components divided by 3, so we get this. The unit factor means the magnitude of the factor is 1. So of course, if you find the magnitude here, of course it's 1. And position displacement factors. So if we have point A, point B, this is factor AB from A to B. This is the factor BA from B to A. Of course, they have the same magnitude, same length, but in opposite direction, 180 degrees direction. So we can say the AB is equal to minus BA. So if we use this example, A minus 3 minus 2, B 5 4, the origin is O 0 0. Position or point factors, so OA, position of point A, we can use small a, minus 3 minus 2, position B minus 5 4, and the displacement, the factor from A to B, 8 6, BA minus 8 minus 6, and as you can see, they are the opposite because they are in the opposite direction. Now we have the factor like forming like a triangle. AB plus BC, factor A, you go from A to B and then you go from B to C. Of course, the shortcut is from A to C. So this makes sense. So if you have like the same letter in the middle, it's an addition, same letter, you can like cancel out, you get AC. And of course, if you move this AB to the right, it's a subtraction. BC equals AC minus AB, and this makes sense because BC equals AC minus BA. We replace AB with minus BA. Minus minus becomes plus. And if you switch the order BA first and then AC, you can see it's an addition now, same letter, you can cancel out. So again, this is BC. So that's the concept. Next we have you use the same example. The factor AB is 8 6. So we can find the factor AB using the concept that this is the same as AO plus OB, addition, same letter in the middle, they cancel out, we have AB, right? Now AO is the same as minus OA. So if we switch the order OB minus OA, we usually use small letter small b minus small a. This means we just do b minus a. So the b is 5 4, the a is minus 3 minus 2, b minus a, you get AB. So to find AB, well, all you do is the coordinates of B minus the coordinates of A. Same thing here for BA, that's the coordinates of A minus the coordinates of B. So that's how you find displacement factors. Now midpoint formula. Remember in coordinate geometry, to find the midpoint of A and B, you have coordinates here, x1, y1, and so on. The midpoint is the average of the x values and the average of the y values at divided by 2. So using the same concept, the midpoint of the factor AB is 1/2 the point factor, or the position factor of A plus position factor of B divided by 2. For example, this is the position of A, position of B. You want to find the midpoint, it's just 1/2 of the sum. Alright, that's it for now. I'll see you again next time.